Okay, our problem number 5. And what problem number 5 does is that it asks us what is the slope of a regression line. So I'm assuming they're talking about the regression line in the context of statistic. That would be the most logical answer. So the slope of a regression line. So the slope of regression line. First, let's talk about the response and explanatory variables. So for linear regression in statistics, you have the y's and you have the x, which is somewhat similar to the y's and x you see in calculus, but not exactly the same. So usually we use the y's as like the explanatory, or we have the y's in like a sample, or we also have the x in a sample, but we're trying to explain the relationship, or trying to visualize the relationship between the y's and the x's. So how we do that is that usually we would use something that's called a scatter plot. So there will be a lot of dots of different values of y's and x's. Over here, we just have a lot of random dots everywhere. What we're trying to do is we're trying to use the least square estimation. We're trying to, or the least square methods. Let's do the least square methods, or whoopsie, Control Shift. The least squared method, the least square method. We're trying to use this method to like fit those little scattered dots, to fit these data points into a line where we minimizes the distance between the square dots to the line that we're going to fit. So that way we can basically find a line that fits the data the best, or that best kind of gives the information of the data. So let's just try to draw a line over here. Usually you would just do it on like a software, because it's kind of hard to just eyeball it, or it's not going to be as accurate if you eyeball it. Say this green line over here is our least square line, or it's our linear regression line, or least square line, depending on how you call it. So the slope of this regression line, which is just the slope of this green line. So again, in order to find the slope, we just find a point. So this point is on the data, and we find another point on the data, find another point on the line, and we're just trying to get the changing y and have the changing x, and trying to find their slope. So their slope, again, just explains the amount of changing y for a certain amount of changing x. So it kind of like projects the changing y in terms of changing in, given that the amount of changing in x. So for example, if we have some new data points, over here, and we know the value of x of this data point, but we don't know the value of y of this data point, and want to try to find the value of y on this data point, so y question mark, we know x. And what we're going to do is that we're just going to try to use this regression line we found, and we're going to try to get the value of x on this regression line. See, here is like on the same line, because it's the same value of x, and x is here, and we're trying to get y, let's just call it y1, and we know the value of y1 on this regression line because we know the slope and we have the equation of the line. So here we're just going to estimate the value of y over here, which is unknown, using the value of y of this line. So yeah, the slope of the regression line has a lot of uses, and linear regression also have like a lot of uses. It's probably the same, it's probably one of the first few concepts that you're going to learn in statistics. So it is quite useful, and this is kind of what the slope of a regression line symbolizes. It basically just helps you, it basically just represents the changing y over changing x and it can give you the change in y if the change in x is already known. Cool. Let's look at the sample solution. Yes, they had the same answer and what we explained here. And yes, they also gave some more background information. And yeah, again, this is kind of what we said. The relationship between the change in y based on x also predicts value of y given the x and tests for like linear relationship. Okay, let's just say something like the solution is correct. Cool. Let's move on to the next problem.